Hello everyone, welcome back to our channel. In today's video, we will be discussing about parabola part 2. Okay, so in previous video, we already discussed the basic parts of parabola and we've been solving some problems involving parabola. Now at this point, you will be exposed to another part of parabola which we call it Latus rectum, and you will be solving problems involving the focal diameter or endpoints of the focal diameter, as well as we will be exposed on different word problems on the applications of parabola. Okay? By the way, if you are new to my channel, please don't forget to subscribe. Just hit the like button and please feel free to write your comments down below, and I hope that you will be enjoying in our second part of parabola discussion. Okay, so let's get started. Channel. Now at this point we are going to discuss parabola part 2. So let's start. So let us recall the concept of parabola in this video. So most of the parts of parabola has been discussed or have been discussed in the previous video. Well, anyway, in this video we will still going to discuss and repeat the same part, so you will be refreshed with the concepts regarding parabola. Now, a parabola is a set of points in a plane that are equidistant from a fixed line, the directrix, and a fixed point, the focus. So for any point Q that is on the parabola, so take a look at this graph. This is the Cartesian plane and you have here the parabola. If this is your directrix, this is your focus, of course this is your vertex, and if from the focus to any point on the parabola, we can have it as d sub 2, and from that point to the directrix that is perpendicular to the directrix, you can have that as d sub 1. So if d sub 2 is equal to d sub 1, then that is actually the definition of parabola. Okay, now the latus rectum of a parabola is a line segment that passes through the focus and is parallel to the directrix and has its endpoints on the parabola. So this is now our latus rectum. This has been mentioned but not well thorough discussed on the first video. So if this is our focus, we have this latus rectum. So this is actually the endpoints. We call it endpoints of the focal diameter or endpoints of the latus rectum. So this is parallel to the directrix. So if this is our latus rectum, this is parallel to the directrix and has an endpoints on the parabola. Now the length of the latus rectum is the absolute value of 4p. Okay, the absolute value of 4p, that is the total length of the latus rectum, where p is the distance from the vertex to the focus. Okay, again, p is the distance from the vertex to the focus. Okay, that is the relationship. And then the distance from this point towards this another point, this is the length of the latus rectum, which is equivalent to the absolute value of 4p. Okay, so there are things that you should already know about parabola. There are forms of equations. If you have y is equal to a to the quantity of x minus h quantity squared plus k, it opens up if a is positive. Again, in the previous lesson or previous video, we use actually c for the variable c for us to tell whether the parabola opens upward, downward, to the left, or to the right. Okay, but in here, for the sake of this video, okay, again, the letters such as C, A, and P are used interchangeably, so do not be confused with this. So if we are going to go back, this is actually our standard form. of the parabola. You can have this, if you're going to transpose this k to the other side, that is y minus k. Then you have opens up if a is positive, and then opens down if a is negative. Then vertex is at hk. Then y is equal to ax squared plus bx plus c. It opens up if a is positive and opens down if a is negative. Meaning if this is the equation of the parabola expressed in terms of y, then the parabola opens up if a is positive and opens down if a is negative. And the vertex will be solved if this is the equation given as negative b over 2a, then f times negative b over 2a. Thus far in this course, we have studied parabola that are vertical, that is, they open up or down, and the axis of symmetry is vertical. Then in this unit, we'll also study parabolas that are horizontal, that is, they open right or left, and the axis of symmetry is horizontal. So this is now the orientation of the parabola. So in these equations, it is the y variable that is being squared. So x is equal to a times the quantity of y minus k squared plus h. Or x is equal to a y squared plus by plus c. Equations of a parabola, if x is ay squared plus by plus c, that's horizontal parabola. Okay, by the way, so we'll just disregard this one because it talks about the hyperbola. Let's proceed. Okay, this one. The standard form of equation of a parabola. If it is y minus k quantity squared is equal to 4p x minus h, this is the horizontal parabola. And x minus h quantity squared is equal to 4p minus k, this is the vertical parabola. Then the vertex will be hk, the vertex will be here also is hk. And if 4p is greater than 0, it opens to the right. If 4p is less than 0, opens to the left. So this is just simply a review of the first video lesson. Here, if 4p is greater than 0, it opens up. And if 4p is less than 0, it opens down. The directrix is vertical. The vertex is midway between the focus and directrix. Midway meaning it's the middlemost point. The directrix is horizontal and the vertex is midway between the focus and directrix. Now remember that the absolute value of p is the distance from the vertex to the focus. Again, in the previous lesson, we used the variable c instead of p. So for parabola definition, all the points x, y equidistant from a fixed line called directrix and a fixed point called the focus. The standard form for the vertical, 4p times the quantity of y minus k is equal to x minus h squared. Then you can express it like this: y is equal to 1 over 4p times x minus h quantity squared plus k. For the horizontal axis of symmetry, you have 4p x minus h is equal to y minus k quantity squared. And if it's expressed in terms of x, you have x is equal to 1 over 4p times y minus k quantity squared plus h. And the directrix would be x is equal to h minus p, where the vertex is hk and p is the directed distance to the focus. There are forms of parabola. Y squared is equal to 4ax, y squared is equal to negative 4ax, x squared is equal to 4ay, x squared is equal to negative 4ay. Okay, again, a here, on the previous video, we used the variable c instead of a. So the equation of the axis y is equal to 0, here also y is equal to 0, this one x is equal to 0, then this is x equal to 0. The equation of the directrix is x equal to negative a. The vertex is 0, 0. Same is true with this one. X is equal to a. Here, y is equal to negative a for this one. And then y is equal to positive a. Okay, then for the vertex, that is 0, 0 all throughout, because this is the equation of the parabola when the vertex is at the origin. The focus will be A0, here negative A0, 0A, then 0, negative A. And the length of the latus rectum are all 4A. Okay, again, A can be expressed as C or P. It depends on the textbook or the article that we're using or basing. Okay, so for the parabola, again, if you're going to have it in graph, this is the equation now when the vertex is at the origin, and this is the corresponding graph. I know that you have familiarized already the equations as well as the graph, but again, this is just a sort of a refreshment. And this is the focus. This is the length of the latus rectum, which is the same. The equation of the directrix, the equation of axis or the axis of symmetry. Okay, I will not read by one because this is already presented in the previous slide. So general note, standard forms of parabola with vertex HK. So the table summarizes the standard features of parabolas with a vertex at point HK. So the axis of symmetry y is equal to k when y minus k quantity squared is equal to 4p times x minus h. Again, p and c is just the same. The focus will be h plus p, then k. The directrix is x is equal to h minus p. And the endpoints of the focal diameter, okay, you have to take note of this one because this has not been mentioned in the previous video lesson. So the endpoints of the focal diameter, it's h plus p, then k plus and minus 2p. Then the axis of symmetry, if x minus h, the equation is x minus h quantity squared is equal to 4p, y minus k. The focus is h, k plus p. The directrix is y is equal to k minus p. Then the endpoints of focal diameter, again, you have h plus and minus 2p, then k plus p. Okay, so this is the additional concepts that you will be learning in this video. So you have it here. So considering you have this orientation of the parabola that opens to the right and to the left, and of course the axis of symmetry is horizontal. You have y is equal to k. Okay, so we're going to focus our attention now. So this has a standard form of y minus k quantity squared is equal to 4p x minus times x minus h, where p is greater than 0. That is why the parabola opens to the right. And this one, again, remember, you have the same formula, standard formula, only that here p is less than 0, so it opens to the left. If p is less than 0, then later on, the moment you substitute the values, then this will be negative here. Okay, well anyway, let's focus on the graph. So this is the vertex, this is the focus, this is your directrix, and this is your endpoints of the focal diameter. Okay, endpoints of your latus rectum. The endpoints of your latus rectum, if this is the orientation of the parabola, would be h plus p, then k plus 2p. Here, h plus p, then k minus 2p. Remember, the distance from this point, okay, from this point towards that another endpoint is 4p. Okay, this one is the same. It's if it opens to the left, you have the vertex, you have the focus, and you have the endpoints of the focal diameter. Then this will become h plus p, k plus the absolute value of 2p. Okay, the absolute value of 2p. Then here will be h plus p, then k minus the absolute value of 2p. Okay, let's continue. So if the axis of symmetry is vertical, so you have here the vertex, you have the focus, and the directrix. By the way, if you've noticed that I won't going to discuss one by one in this graph, that is because you already mastered the parts of parabola on the previous video lesson. However, I will try to emphasize more on the endpoints of the focal diameter because this is the one that has not been mentioned by the previous video. So here, if the parabola opens upward, then this will be your endpoint, one of the endpoints of the latus rectum or focal diameter. You have h minus 2p, then k plus p. This one also h plus 2p, then k plus p. Remember, you might be asking, why is it 2p? Remember, the whole thing here, the length of the latus rectum is 2p. And the length from the focus to the vertex is only p or c. Okay? Again, p and c are used interchangeably. That's just the same. Therefore, this is 2p. The distance from the focus to the endpoint here is 2p. This is also 2p. Okay? Now, it opens upward when p is greater than 0. Here, the same standard formula, but when p is less than 0, it opens downward. And this will be your endpoints of the latus rectum. So you will have, this is your focus, this is your vertex, this is your directrix, and this is your latus rectum, and the endpoints of the latus rectum would be h minus the absolute value of 2p, then k plus p. Here, h plus the absolute of 2p, then k plus p. Later on, we'll apply those concepts on the problem. Now, how to? Given a standard form equation for a parabola centered at hk, sketch the graph. Now, determine if the standard forms applies to the given equation y minus k quantity squared is equal to 4p x minus h, or x minus h quantity squared is equal to 4p y minus k. Use the standard form identified in step 1 to determine the vertex, axis of symmetry, focus, equation of the directrix, and endpoints of the focal diameter. So if the equation is in the form of y minus k quantity squared is equal to 4p x minus h, then use the given equation to identify h and k to the vertex hk. Use the value of k to determine the axis of symmetry wherein y is equal to k. Then set for p equal to the coefficient of x minus h in the given equation to solve for p. And if p is greater than 0, then the parabola opens right. Or if p is less than 0, the parabola opens left. Use hk and p to find the coordinates of the focus. You have h plus p, then k. Use h and p to find the equation of the directrix. You have x is equal to h minus p. Then use hk and p to find the endpoints of the focal diameter. You have h plus p, then k plus and minus 2p. So basically, this is the flow or the order of the solutions if this is being asked. Okay, let's proceed. Now, if the equations, how about the other way around? If the equations is in the form of x minus h quantity squared is equal to 4p times y minus k, meaning this equation is where the axis of symmetry is vertical. So use the given equation to identify h and k for the vertex hk. Use the value of h to determine the axis of symmetry x is equal to h. Then set for p equal to the coefficient, again the coefficient of y minus k, in the given equation to solve for p. If p is greater than 0, then the parabola opens up. Again, p and c can be used interchangeably. So if p is less than 0, the parabola opens down. Use hk and p to find the coordinates of the focus hk plus p. Then use k and p to find the equation of the directrix y is equal to k minus p. Then use h, k, and p to find endpoints of the focal diameter, which is h plus and 2 plus and minus 2p, then k plus p. Then plot the vertex, axis of symmetry, focus, directrix, and focal diameter, and draw a smooth curve to form the parabola. Now, let's try. Graphing a parabola with vertex hk and axis of symmetry parallel to the x-axis. Now, graph y minus 1 quantity squared is equal to negative 16x plus 3. identify and label the vertex, axis of symmetry, focus, directrix, and endpoints of the focal diameter. So in this problem, it is different from the previous video lesson because we didn't mention the focal diameter. Okay. Now, the solution, the standard form that applies to the given equation is, okay, after having this given, focus or try to recall what equation that fits in this given. So that is actually the standard form of the equation is y minus k quantity squared is equal to 4px minus h. Thus, the axis of symmetry is parallel to the x-axis. So it follows that the vertex is hk, which is negative 3, that is x minus h. So that is negative 3, and this is y minus k, so this should be 1, negative 3, 1. And the axis of symmetry, y is equal to k is equal to 1. Then, next would be to find p. So equate the numerical coefficient of x plus 3, which is negative 16. So negative 16 is equal to 4p. Then p is equal to negative 4. Since p is less than 0, the parabola opens to the left. Okay, once we identify the orientation of the parabola now, we are now ready to solve using the rest of the formula to find the coordinates of the focus, directrix, and the focal diameter. So we'll have the coordinates of the focus are h plus pk is equal to negative 3 plus negative 4, 1 is equal to negative 7, 1. The equation of the directrix is x is equal to h minus p is equal to negative 3 minus negative 4, which is equal to 1. Then the endpoints of the focal diameter are h plus p, k plus and minus 2p, that is negative 3 plus negative 4, then 1 plus and minus 2 times negative 4. The answer will be negative 7, and negative 7 over 9. So where did you get negative 7? So here, 2 times negative 4 is negative 8. So 1 plus negative 8 is negative 7. So that will be your first value of your y. The second is 1 minus negative 8. 1 minus negative 8 is positive 9. So the endpoints of the focal diameter then are negative 7, and negative 7, positive 9. Okay, I hope that you are able to follow the procedure. Okay. Next, we plot the vertex, axis of symmetry, focus, directrix, and focal diameter and draw a smooth curve to form the parabola. So this is now the graph. So this is your vertex, this is your focus, this is your focal diameter, and these are endpoints of your focal diameter, negative 7, here is negative 7, 9. Okay? And this is the equation. And this is your directrix. And this is your axis of symmetry. Okay? Let's continue. Now, next example. Graph y plus 1 quantity squared is equal to 4 times x minus h. Identify and label the vertex, axis of symmetry, focus, directrix, and endpoints of the focal diameter. Now, vertex is h negative 1. Okay. This one is just very easy. We'll just present the graph right away as well as the answers. So, vertex is 8, negative 1. The axis of symmetry is y is equal to 1. The focus is 9, 1. 9, negative 1, I mean. The directrix is x is equal to 7. Here. Endpoints of the latus rectum are 9, negative 3. And 9, positive 1. Okay. By the way, I want you, in this part, I want you to present the solution of this part. Provide the solution, the same as this one. Okay. Now, let's continue. Example. Again, graphing a parabola from an equation given in general form. Now, if we have here graph x squared minus 8x minus 28y minus 208 is equal to 0, Then identify and label the vertex, axis of symmetry, focus, directrix, and endpoints of the focal diameter. Now for the solution, start by writing the equation of the parabola in standard form. The standard form that applies to the given equation is x minus h quantity squared is equal to 4p times y minus k. Now the axis of symmetry is parallel to the y-axis. So to express the equation of the parabola in this form, we begin by isolating the terms that contains the variable x in order to complete the square. So we will have like this: x squared minus 8x minus 28y minus 208 is equal to 0. Then x squared minus 8x is equal to 28y plus 208. Then x squared minus 8x plus 16, that is negative 8 to complete the square. Negative 8 divided by 2 is negative 4. Then negative 4 squared, that is positive 16. Since we add positive 16 in this side of the equation, we also add 16 on the other side of the equation. Then, since it's already a perfect square trinomial, that can be factored as x minus 4 quantity squared is equal to 28y. 208 plus 16 is 224. Then x minus 4 quantity squared is equal to, the greatest common monomial factor exists between 28y and 224 is 28. So 28y divided by 28 is y, then 224 divided by 28 is 8. Therefore, you have x minus 4 quantity squared is equal to, okay, you have 4 times 7 y times y plus 8. Why is it 4 times 7 here? Again, this came from the equation for p. So we just simply factor out, since 28 is factorable by 4 and 7, so we can separate 4. Then, so we can see if the remaining factor is a positive or a negative number. Okay, since it's positive, it says that, okay, so we will discuss that later on when we are already on the graph. So the vertex is hk, so you have 4, negative 8. The axis of symmetry is x is equal to h, which is equal to 4. And since p is equal to 7, so p is greater than 0, and so the parabola opens upward. So the coordinates to the focus are h, k plus p is equal to 4, then negative 8 plus 7, which is 4, negative 1. The equation of the directrix is y is equal to k minus p. That is equal to negative 8 minus 7 is equal to negative 15. The endpoints of the focal diameter are h plus and minus 2p. You have k plus p. Then is equal to 4 plus and minus 2 times 7. Then we have negative 8 plus 7, or the answer is negative 10, negative 1, and 18, negative 1. Okay. You might be asking, where did we get these answers? Again, here, h plus 2p, you have 4 plus 2p. So 4 plus 2 times 7 is 14. Okay. So we have here okay, 2 times 7 is 14, then 4 plus 14 is 18. Then we have here 4 minus 2 times 7. 2 times 7 is 14, then 4 minus 14 is negative, you have here negative 10. Then negative 8 plus 7 is negative 1. Okay. Then the same here, negative 1 and negative 1. Next, we plot the vertex, axis of symmetry, focus, directrix, and focal diameter, and draw a smooth curve to form the parabola. So we have here the endpoints of the focal diameter. You have negative 10, negative 1. Here is 18, negative 1. You have the focus for negative 1. You have the vertex for negative 8. You have the directrix x is equal to 4. Then you have, the axis of symmetry x is equal to 4. and the directrix is y is equal to negative 15. And this is the equation of x minus 4 quantity squared is equal to 28 times y plus 8. Okay. Let's have another example. Graph x plus 2 quantity squared is equal to negative 20 y times y minus 3. Identify and label the vertex, axis of symmetry, focus, directrix, and endpoints of the focal diameter. Then, here's the solution now. The vertex is negative 2, 3. Axis of symmetry, x is equal to negative 2. Focus is negative 2, negative 2. Directrix, y is equal to 8. Endpoints of the Latus rectum, negative 12, negative 2, and 8, negative 2. Okay. So this is now the graph. And the vertex is negative 2, 3. The focus is negative 2, 2. Negative 2, negative 2. Our directrix is y is equal to 8. Our axis of symmetry is x is equal to negative 2. And the endpoints of the focal diameter is negative 12, negative 2, and 8, negative 2. And this is now the graph of the equation x plus 2 quantity squared is equal to negative 20 times y minus 3. Okay, let's continue. So find the standard form of the equation of the parabola given the focus is 2, 4 and the directrix is x is equal to negative 4. The vertex is midway between the focus and the directrix, so the vertex is negative 1, 4. If you're having a hard time to find the vertex, you're going to use the midpoint formula. Okay? Now, the directrix is vertical, so the parabola must be horizontal. And since the parabola is always inside, the focus is always inside the parabola, it must open to the right. So, the standard formula of the parabola with vertex hk and opens to the right is y minus k quantity squared is equal to 4p times x minus h. The absolute value of p is equal to 3. Now, equation is y minus 4 quantity squared is equal to 12 x plus 1. Okay. So, since we are given the absolute value which is 3, and since it opens to the right, meaning 3 is positive, so 4 times 3, that's 12. So, we got this one. So, since we already have the vertex, we just simply substitute the vertex to h and k. Since our h is negative 1, x minus h, that becomes x plus 1. And our k is 4, that's y minus k. We have here y minus 4. So, this is now the standard form. Okay. Another, find the standard form of the equation of the parabola given the vertex is 2, negative 3 and focus is 2, negative 5. Now, because the location of the vertex and focus, this must be vertical parabola that opens down. Okay? Because after you plot the points, and if you have the vertex, here's the focus, then you know that the focus is always inside the parabola. Therefore, the parabola opens downward. If it opens downward, so the axis of symmetry is vertical. Therefore, the standard equation or formula that we're going to use would be x minus h quantity squared is equal to 4p times y minus k. The absolute value of p is 2. Now, the equation we have here, x minus 2 quantity squared is equal to negative 8. You might be asking why negative 8? You have here 4p. And since p is negative 2, because it opens downward, we will have here 2 times 4, and 4 times negative 2, that's negative 8. Then y plus 3. So, the vertex is midway between the focus and directrix. So, the directrix for this parabola is y is equal to negative 1. Okay, so this is the directrix. Okay, let's continue. Graphing a parabola, y plus 3 quantity squared is equal to 4 times x plus 1. Find the vertex, focus, and directrix, then graph the parabola. Vertex is negative 1 and negative 3. The parabola is horizontal and opens to the right. Since 4p is equal to 4, this is the numerical coefficient of x plus 1, then p is equal to 1 because 4 divided by 4 is 1. The focus is 0, negative 3. Directrix is x is equal to 2. If we're going to express this 1 into this expression, we have x equal to 1/4 y plus 3 quantity squared minus 1. Okay? You can also have, you can end up at like this, the endpoints of the focal diameter, or you can have more points, 2 more points. You can have, if x is 0, y is negative 1, 0, and negative 5. Then if x is 3, y is 1 and negative 7. So that's why you have this one. Okay, so it's very easy to find the points because all you have to do is set x with one value and you can already have 2 y values if this is the orientation of the parabola. Because remember, it is symmetrical. Okay, converting an equation. Convert the equation to standard form. Find the vertex, focus, and directrix. So if you have y squared minus 2y plus 12x minus 35 equals 0, so to complete the square, negative 2 divided by 2 is negative 1. Negative 1 squared is 1. Add here, you also add here the same number. So y squared minus 2y plus 1 is equal to negative 12x plus 35 plus 1. Then y minus 1 quantity squared is equal to negative 12x plus 36. Copy y minus 1 quantity squared. The greatest common monomial factor between negative 12x and 36 is negative 12. Then negative 12x divided by negative 12 is x. 36 divided by negative 12 is negative 3. So the parabola is horizontal and opens left because this is negative 12. The vertex is 3, 1. And 4p is equal to negative 12. Therefore, p is equal to negative 3. The focus is 0, 1. The directrix is x is equal to 6. So this is now the graph. Now solving applied problems involving parabolas. Now as we mentioned at the beginning of the section, parabolas are used to design many objects we use every day, such as telescopes, suspension bridges, we mentioned this in our previous video, then microphones and radar equipment. Parabolic mirrors such as the one used to light the Olympic torch have a very unique reflecting property. When rays of light parallel to the parabola's axis of symmetry are directed toward any surface of the mirror, the light is reflected directly to the focus. This is why the Olympic torch is ignited when it is held at the focus of the parabolic mirror. Okay, so considering we have here, this is the parabolic mirrors. Look at this one. So this is the figure, wherein this is the focus, this is the parabolic reflector, and this is the parallel rays of sunlight. Now, parabolic mirrors have the ability to focus the sun's energy to a single point, raising the temperature hundreds of degrees in a matter of seconds. So, thus parabolic mirrors are featured in many low-cost, energy-efficient solar products, such as solar cookers, solar heaters, and even travel-size fire starters. So, this is now the application of parabola in actual and real-life scenarios. Okay? So you should not think that parabola, solving the parts of parabola is useless, because this is very much applicable in our real life scenarios and inventions. Okay, example, solving applied problems involving parabolas. So a cross-section of a design for a travel-size solar fire starter, the sun rays reflect off the parabolic mirror toward an object attached to the igniter. Because the igniter is located at the focus of the parabola, the reflected rays cause the object to burn in just seconds. Okay, first step, find the equation of the parabola that models the fire starter. Assume that the vertex of the parabolic mirrors is the origin of the coordinate plane. Then use the equation found in part A to find the depth of the fire starter. So this is now your parabola. So we have here the igniter, wherein it is your focus, and this is the 4.5 given 1.7 inches from vertex to the focus, the igniter, and the length of the latus rectum here from this side to that side is 4.5. Okay, 4.5 inches. Okay, you don't know the depth. This is 4.5 here, meaning this length towards this length is 4.5. You cannot see it here, but it's 4.5 inches. Okay, now the solution. The vertex of the dish of the origin of the coordinate plane. So the parabola will take the standard form x squared is equal to 4py, where p is greater than 0. The igniter, which is the focus, is 1.7 inches above the vertex of the dish. Thus we have p is equal to 1.7. Now x squared is equal to 4py. This is actually the standard form of upward facing parabola with vertex 0, 0. Then x squared is equal to 4 times 1.7y. Substitute 1.7 for p. Then x squared is equal to 6.8y when you multiply. So the dish extends 4.5 over 2 is equal to 2.25 inches on either side of the origin. So we can substitute 2.25 for x in the equation from part A to find the depth of the dish. So x squared is equal to 6.8y. That's equation find in part A. Then 2.25 squared is equal to 6.8y. We substitute the value of x. Then to solve for y is approximately 0.74. Okay, so this is now the answer. Okay, so this is now the length. Okay, this is now how the length, the answer for this question. Okay, use the equation found in part A to find the depth of the fire starter. So the answer, how depth is the fire starter, this one is 0.74 inches. Okay, that's the value of our y. Okay, now let us proceed. Another application. A satellite dish is in the shape of a parabolic surface. The dish is 12 feet in diameter and 2 feet deep. How far from the base should the receiver be placed? So you have it here, 12 feet in diameter. So that is our focal diameter. And 2 feet deep. 2 feet deep. So that would be from your focus to the vertex. Okay, the question is, how far from the base should the receiver be placed? So consider a parabola cross-section of the dish and create a coordinate system where the origin is at the base of the dish. So you will have it here. Okay, since you know that the focal diameter or the length of the latus rectum is 12, so automatically it will, and diameter, it has 2 feet deep here. So from this focus to here is 2 feet. So automatically you will have the endpoints of the latus rectum or focal diameter is negative 6.2 and 6.2. They consider, since the parabola is vertical, the axis of symmetry is vertical, and as its vertex at origin 0, 0, so its equation must be of the form x squared is equal to 4py. So at 6.2, if you're going to substitute the value of x, so this will be 6 squared, that's 36, is equal to 4p, y is 2, so you have here 2. Then to solve for p, you will have 36 is equal to 4p times 2, so 36 divided by 2 is 18. 18 divided by 4 is 4.5. Therefore, P is 4.5. Thus, the focus is at the point 0, 4.5. So, it is here. Okay, the focus is 0, 4.5. Now, the receiver should be placed 4.5 feet above the base of the dish. Okay. Another application. The towers of a suspension bridge are 800 feet apart and rise 160 feet above the road. The cable between them has the shape of a parabola, and that cable just touches the road midway between the towers. So this is now the suspension bridge. Okay, and you have here the cables and the two towers here and this one, and the road midway between the towers is here. So the question is, what is the height of the cable 100 feet from the tower? Okay, this is 100 feet from the tower. We are asked to find the height of the cable 100 feet from the tower. Since the parabola is vertical and has its vertex at 0, 0, its equation must be of the form x squared is equal to 4py. So at point 400, 160, so this becomes, you substitute 160 squared is 160,000. Then 4py, copy 4p, and value of y is 160. Then divide both sides by 160. Here it becomes 1000 equals 4p. Divide both sides by 4 to find the value of p. Therefore, our p is equal to 250. Okay, thus the equation is x squared is equal to 1000 y. Because we already found the value of p. Now at 300 h, so we can actually use here, that becomes 90,000, because we substitute 300 to the value of our x, so that is 300 quantity squared, or 300 squared, that is 90,000. Then 1000 y, our y, you have 1000 y. So our y, we are going to replace y with h. We don't know h yet. So divide both sides by 1000 to find h. Therefore, the answer is h is 90. So the cable would be 90 feet long at a point 100 feet from a tower. Okay. So again, this is again the overview of the parabola. The parabola is the locus of all points in a plane that are the same distance from a line in the plane. The directrix as from a fixed point in the plane focus. Okay, so we know this already. You have understood this already, that the parabola has one axis of symmetry which intersects the parabola at its vertex, like that. And the distance from the vertex to the focus is the absolute value of p. Okay, and the distance from the directrix to the vertex is also the absolute value of p. Then the standard form of the equation with vertex hk for a parabola with the axis of symmetry parallel to the y-axis and vertex as hk, the standard form is x minus h quantity squared is equal to 4p y times y minus k. So I won't be discussing this again and again. I will just play this one because we already discussed this in the previous slides and previous video. Okay, because you mastered this already. The same is true with this one. Okay, if the axis of symmetry is horizontal, so you have here y minus k quantity squared is equal to 4p x times x minus h. And you have this N4 details of this particular equation. The equation of the axis of symmetry is y is equal to k. The coordinates of the focus are h plus p, then k. The equation of the directrix is x is equal to h minus p. When p is positive, the parabola opens to the right, and when p is negative, the parabola opens to the left. And this is now the graph. Okay, I won't reiterate this again because we've been discussing this in our previous video. So finding the equations of the parabola. Okay, so let's have another kind of review if you have a problem. Write the equation of the parabola with a focus at 3, 5 and directrix at x equal to 9 in standard form. The distance from the focus to the directrix is 6 units. Therefore, 2p is equal to negative 6, then p is equal to negative 3. Thus, the vertex is 6, 5. The axis of symmetry is parallel to the x-axis. Okay, so you have here the y minus k quantity squared is equal to 4p, x minus h is equal to 6, and k is equal to 5. Y minus 5 quantity squared is equal to 4 times negative 3, then x minus h times x minus h. Y minus 5 quantity squared is equal to negative 12 times x minus 6. That's a standard form. Okay, finding the equations of the parabola. Okay, how about if it's presented like this? Finding the equation of the parabola that has a minimum at negative 2, 6 and passes through point 2, 8. Okay, how are we going to do this one? So first and foremost, we need to analyze what does the term minimum stands for, or what does it mean. So when you say minimum, this is actually the lowest point, okay, of the parabola. So if it's negative 2, 6 and that's the minimum point, then it gives us an idea that the parabola opens upward and that negative 2, 6 is the vertex. And it passes through the point 2, 8. So we'll just choose, we have here 2, 8. So if we're going to graph it, it looks like this. So the axis of symmetry is parallel to the y-axis here. And then substitute into the standard form of the equation and solve for p. So this is what you're going to solve. So since the axis of symmetry is vertical and it opens upward, we will use x minus h quantity squared is equal to 4p times y minus k. Then x is equal to 2 and y is equal to 8. Then next would be, we have points here again. Since x is equal to 2 and y is equal to 8, we are going to replace, okay, these points 2, 8, we're going to substitute the values of x and y, so we can solve for p. Okay, and we also substitute the value of hk, which is negative 2 and 6. So you have 2 times negative 2 quantity squared is equal to 4p, 8 minus 6. Then we have 2 minus 2. 2 minus negative 2 is 4. Then 4 squared is 16. Then 8 minus 6, that is 2. 2 times 4p is 8p. Then p will be equal to 16 divided by 8 is 2. Okay, our p is 2 now. So let's go back to the standard form and substitute the value of p. So x minus negative 2, that is our h, and then our k is negative 6, positive 6, and our p is 2. So we have here x plus 2 quantity squared is equal to 8, y minus 6. This is now the standard form. Okay, so even if we're given the vertex and then given the point on parabola, we can still solve for the standard form. Okay, next. Analyzing a parabola, find the coordinates of the vertex and focus, the equation of the directrix, the axis of symmetry, and the direction of opening of 2x squared plus 4x minus 2y plus 6 equals 0. So this is the general form. So we are going to express this into standard form. So you have 2x squared plus 4x, it's here. So we transpose 2y minus 6 to the other side of the equation. Remaining is x squared plus 2x. Remaining is 2x squared plus 4x, and then the greatest common monomial factor is 2. So we place 2 outside the parentheses. Then 2x squared divided by 2 is x squared. Then 4x divided by 2 is 2x. Next would be, we are going to do completing the square. To complete the square, we have here 2x divided by 2 is 1. 1 squared is 1. So if we are going to add 1 here, we'll also add on the other side. Then here, since we have here 2 already, so 2 times 1 is 2. So that's why we add 2 times 1 here. Next, it becomes 2 times the quantity of x plus 1 quantity squared is equal to 2y minus 6 plus 2. Negative 6 plus 2 is negative 4. Then 2y minus 4, the greatest common monomial factor is 2. Then it becomes 2 times y minus 2. So we will have x plus 1 quantity squared. Divide both sides by 2. So we have x plus 1 quantity squared is equal to y plus minus 2. Then 4p is equal to 1. Consider that there is 1 here. Then p will be equal to 1/4. Then the parabola opens to upward because our value of p is positive. Okay, it looks like this one. Okay. So the graph of y is equal to x squared plus 2x plus 3. The vertex is negative 1, 2. The focus is negative 1, 2, and 1/4. The equation of the directrix is y is equal to 1 3/4. Then the axis of symmetry is negative 1. Okay. Now, graphing a parabola, y squared minus 10x plus 4y minus 16 equals 0. Complete the square. We have this one. 4y divided by 2, that is 2. Then square 2, they have 4. You add 4 here, you also add on the other side. Then it's already perfect square. Y plus 2 quantity squared is equal to 10x plus 20. Then we have 10x plus 16 plus 4, that's 10x plus 20. Then y plus 2 quantity squared is equal to 10x plus 20. The greatest common monomial factor is 10. We have 10 times x plus 2. Horizontally oriented and facing to the right because here our 4p is positive. And y plus 2 is quantity squared. So the vertex is negative 2, 2. Negative 2, negative 2. That the line of symmetry is negative 2. Our p is 2.5. So the focus is 0.5, negative 2. The directrix is x is equal to negative 4.5. Okay. Now, let us proceed to the assessment now. I hope that you understand more examples when I give you more examples and different problem solving or different word problems. Okay, so note here, solve also the endpoints of the focal diameter and graph the parabola. So find the focus, vertex, equation of directrix, and length of the latus rectum of the parabola. Y squared is equal to 12x. Then y squared is equal to negative 8x. Then y squared minus 8x minus 2y plus 17 equals 0. Then x squared is equal to 5y. Then x squared minus 8y minus 2x plus 17 equals 0. Then x squared is equal to negative 16y. Then find the focus, vertex, equation of directrix, and length of the latus rectum of the parabola of x squared plus 4y minus 6x plus 17 equals 0. Okay. I hope that you can answer this by pair. And always remember that you also have to solve the endpoints of the focal diameter or the endpoints of the latus rectum. And you're also going to graph the parabola and label its parts. Okay? So to end this video, let's have a math code. Good mathematics is not about how many answers you know. It's how you behave when you do not know. It is from an unknown author. So thank you so much, and don't forget to subscribe my channel. Bye!